What's up, team? Today we're talking about angles that are formed by chords. First, two quick reminders. First, vertical angles are always congruent. So in this little demonstration here, angles 1 and 3 must have the exact same angle measure. They're congruent. In the same way, 2 and 4 are congruent. That's not new, that's old, but we're going to use it today. Next reminder, this one's fairly recent. A central angle and a minor arc it intersects have the same exact measure. So in this case, angle A, B, C, that's the central angle. It's given to us that that's 110 degrees. So if we were asked what's the measure of arc AC, we would say it's also 110 degrees. That's something we learned in a previous lesson. Check out that video if that is news to you. Here's the new stuff. It's not entirely true. Let's explore a situation here. Say we have two diameters that intersect. We're given that angle AXC is 30 degrees. We know by vertical angles that this angle BXD is also 30 degrees. That's the first reminder. The second reminder over here, the central angle and minor arc have the same exact measure, meaning that arc AC have a measure of 30 degrees, arc BD have a measure of 30 degrees. Cool, so far it's easy, but not especially interesting. Here's a relationship I want to explore that's going to seem really trivial, but it's going to apply to a bigger case where it actually is helpful for us. Notice, if we add up both of these arc measures here, in this case we'll do 30 plus 30, those are the arc measures, and then we divide that sum in half. Again, this isn't especially interesting for this case here, but it's going to apply. We're going to end up with 60 over 2, which is 30. What I want to point out to you is that these two angles measure the 30 degrees. So if you take your two arc measures, you add them together, you chop them in half, you're going to get 30 degrees. Again, not especially interesting in this case because it's all 30 and that's no surprise. But that's going to apply in a case like this. What if you have two chords that intersect that don't intersect in the center of the circle? Well, this still applies. This idea still applies. So we're going to explore that next. I'm going to clean this up and give myself a little bit more space. Okay, here we go. There's a whole bunch of stuff we're going to explore. I'm going to try to zoom through it. Feel free to rewind, pause, whatever you need to do to make sure you get all the pieces here. So we're going to answer all 6 of these questions, find all these different measures. First, the measure of angle BXD. Let's find it. B to X to D. Well, it looks like it lies on the same line AB, so these are linear pairs, meaning that the angle BXD and AXD must be supplementary. They add up to 180 degrees. That makes this angle here 120 degrees. So 120 degrees. And again, the reason why we know this is because these two have to add to 180, so we subtracted 60. So showing my work, I would do, something along those lines. Okay, now arc AD, that's this business right here. Our second reminder from a moment ago, hang on, that doesn't quite work for us. Because that's when you have a central angle. We don't have a central angle this time around. So we're going to use that property that we explored a moment ago, however. So we know that 60 equals, well, we're going to take our two arcs, 75 and whatever that is. So it's going to be 75 plus the measure of arc AD over 2. So this is the property that we explored a moment ago that I said, hey, it's not interesting. They're all 30. Well, here's where it gets interesting, right? Because now we want to solve for the measure of arc AD, and the rest of the stuff we have here is numbers. So we have a kind of an algebra 1 problem. Multiply both sides by 2, and we learn that 120 equals 75 plus the measure of arc AD. Subtract 75 from both sides, and we get 45. So 45 equals the measure of arc AD. Did I do that right? 45 plus 75? Yep, that adds up. So this here is 45 degrees. This here is 45 degrees. Whew. Okay, let's keep rolling. The measure of arc AC. That is this big arc here. Well, we know that 120 equals 72 plus this stuff divided in half. So that means 120, that's the measure of angle BXD, equals 72 plus the measure of arc AC this time over 2. Okay, multiply both sides by 2, we get 240 equals 72 plus the measure of arc AC with the whoop-de-doo on top. Subtract 72 from both sides. 240 minus 72, that's going to be 8. This turns into a 3, that turns into a 6, and then we have 1 left over here. So the measure of arc AC is 168 degrees. Let's capture that. 168 degrees. 168 degrees. There it is. Okay, next. The next two are angle measures. These two are easy to find. I'm also noticing I put this one on here twice. Cool, go me. We're only going to do it once because it's all we need. So the measure of angle CXB, that is C to X to B, well, this is just vertical angles. These are opposites, so this is 60 degrees. Cool, easy peasy. Not even going to show any work here. Next, angle AXC, A to X to C. That's also a vertical angle here with the 120. So here we go. We now have all four of these angles on the inside. We have all four of the arc lengths on the outside. Again, the kicker here is the angle measures, again, opposites are always going to be congruent, and the way you find it is you add up the two intersecting arcs and divide them in half. So in this particular case, 45 plus 75 equals 120. Half of that is 60. Similarly, 168 plus 72, that equals 240. Half of that is the 120. There we go. This is how you find angles that are created by chords that are not in the center of your circle. Let's dive into some practice problems. Let me know if you have questions. You got this.